what I found out about what's going on with this machine and this project with the Vilmill. This machine has been set up in metric, and I also want to let you know that I have milled the calibration block to be flat and parallel to the gantry, so you can touch off and it will give you an exact height on the tooling. We're shipping the tooling with you, but we're only providing you 2 6mm collets. We don't have any tooling really to send to you, so you'll have to provide a 4mm aluminum end mill cutter, and there is still one good V cutter that I've used, and it's all worked out fine. The files that I've created cut out perfect. They provide you a fantastic edge quality. Now I want you to look at the dust hood assembly. We have copper lines going into the dust hood, and we've created a phenolic ring instead of brushes. Now, these copper lines actually go through this ring and stop against the bottom of the spindle. You can see here that this actually keeps the hood from going up completely all the way. Make sure that you adjust these. They pretty much shoot right at the bit when the hood is down. Okay, this dust collector ring has very little clearance in this spindle area, so if they take this spindle off, you must make sure that this gets on just right. Now, it does go up and down very nicely. However, you have to make sure it's on there correct. Also, when you adjust the height of this, the tip must come down just below this face. Do not let this ride on the part. Okay, also, I've pretty much gotten the mist down so that when you're cutting the part, the mist is not too much on the part. It might be a little bit less, but the whole idea is not to put a whole lot of mist onto the part, because you have to heat the part up to get the Vilmill to stick. So very little mist and air if you can. Alright, more about the tooling. Make sure this tooling is in there tight. Really take the time to make sure that it's a good collet and that it is properly chucked up and it's very tight. You do not want to mess up these plates. Alright, we cannot afford for these bits to come out. I've cut several of these files now, and they work very, very well. The speeds, the feeds, and all that is going on with these files provides an excellent cut. Alright, the files are loaded into your DNC. So if you want to come up here to utility and go over to DNC mode and then go to local, now when you press the DNC button, it will bring these files up that are actually loaded in the controller, and you don't have to have a computer hooked to the machine at all. This stern file is the little propeller looking little part. You've got 1, 2, 3 of them, a block of 4, and a row of 6. The parts go out in Y-axis. These files, I'll also send you an email, and so I'll give you the en-route files, I'll give you the DNC files, so just in case you don't want to run them from the local DNC, and I'm going to send you the DXF file of what I tool path. I'm also going to send you a DNC file called Fly, F-L-Y, and it's used to table mill what I use to table mill this tabletop, these jig plates. The reason why I'm sending it to you is because it has to come down and cut this direction, lift, come back, and then cut again. If you use the regular table mill where it comes back and forth, it puts a real bad chatter onto the plate. The only reason why I'm going to send you that file is because when you get through shipping it and you actually get it into place, you may want to take off like 0.05 millimeters off the top and just barely skin this so that you know that these plates are perfectly flat to your y-axis, because there's very little tolerance on the Vilmill, so before it cannot go all the way through the Vilmill. So you have to know these plates are perfectly flat to the rail.